Welcome back from the ad break. Before the ad break, we spoke about lines, but what we're going to do is now we're going to talk about tangents, because a tangent is a line and it's a special sort of line. And so what we're going to do is we're going to talk about tangents which are linked to circles. So if we go to the next slide, a tangent, which you would have gone through in geometry, is a straight line that touches the circumference of a circle at only one place. And so this here, the red line, is not a tangent because it touches my circle there and it touches my circle there. Line AB is a tangent because it only touches my circle at point. It only touches my circle once. And so that is a tangent. Now, what's important to remember about tangents, and we're going back to our circle geometry, is that a tangent is always going to be perpendicular to a radius. So if I draw a radius from the center of the circle to the point where the tangent touches the line, that one point where the tangent touches the line, the tangent and the radius are going to be perpendicular. Now, let's jump into our first question. Our first question says, determine the equation of the tangent. Here I can see my tangent in red. To the circle x squared plus y squared equals 25. So the center of the circle is at the origin at the point t, 3, 4. So they want me to calculate the tangent at that point. So when we're talking about an equation, it's a line, and so it's going to be mx plus c. So what I need to calculate is the gradient and the y-cut. The y-cut is going to be here somewhere, but I can't do that by inspection, and I can't do the gradients with 2 points because there aren't 2 points. So how am I going to do this? We're going to do this using what we just discussed about circles, tangents, and radiuses, or radii actually, is that a radius is perpendicular to a tangent. And so I can't work out the gradient of the tangent to start with, but I can go and I can calculate the gradient of the radius. If I have the gradient of the radius, then I can go and calculate the gradient of the line. And so let's do that. The gradient of the the radius from 0, 0, the center to 3, 4. How did we calculate that? Well, I went the y value minus the y value over the x value minus the x value. So let's go y value 4 minus y value 0 over x value 3 minus x value 0. And I get gradients of the radius equal to 4 over 3. Now, because I have the gradient of the radius is perpendicular to the tangent, and we discussed that when lines are perpendicular, it means the product of their gradients is equal to -1. But what we decided is what we can do to find the other gradient is I can just flip over my gradient and change the sign. And so the gradient of my tangent is just going to be, I flip over 4 over 3, I get 3 over 4, and I change the sign from a positive to a negative, and the gradient of my tangent is going to be -3 over 4. And so what I know is my gradient. I still need to go find my y-cut. How do I do that? By subbing in a point. And so I'm going to take this point and I'm going to sub it into my gradients. I'm going to take the y value, put it into y. I'm going to take the x value of 3 and put it into 3. And all I need to do is simplify this equation. This equation isn't nice. So what I'm going to do is I'm going to take out my calculator to make sure that I get this right. I'm going to go, and I'm going to go -3 over 4 times 3 on my calculator, and I'm going to get -9 over 4. I'm going to add 9 over 4 on both sides so that I can solve for c. And I'm going to do that on my calculator. So let me take out my calculator. I'm going to go 4 plus 9 over 4. And this is going to give me 25 over 4. And so I know that my y cut is 25 over 4. My gradient is negative 3 over 4. And so the equation of my line is minus 3 over 4x plus 25 over 4. So to recap, what do? I work out the gradient of my radius. Then I flip it over and change the sign so that I can calculate the gradient of my tangent. And then I sub in the points so that I can then calculate my y-cut. Excellent. So let's move on to the next question. The next question, they say determine the equations of the tangents to the circle given that both lines are parallel to that line. I think the ordering of my slides is mixed up, and so I'm going to move to this question, and then I'm going to come back to that question that was on the previous slide. So let's do this question. It says, determine the equation of the tangent to the circle at this point. Now, this question is a little bit different from the previous question, because in the previous question, I knew where the center was. The center was at the origin. Now, I don't know where the center is, and so it's going to be a little bit tougher for me to calculate the gradient of the radius, right? So what I need to start with is I need to first find the center of the circle. Once I have that, then I can calculate the gradient of my radius and move forward from there. Now, we discussed this when we spoke about circles, all right? But what I'm going to have to do here is I'm going to have to complete the square. So I'm going to write it in a different order. I'm going to put the x's together. I'm going to put the y's together. And I'm going to go and complete the square. Why am I completing the square? So that I can get it in standard form, so that I can know where the center of the circle is, because once I have that, I can work out the gradient of my radius. So what did we decide to complete the square? Is I'm going to take the coefficient of x, divide it by 2, square it, and I'm going to add it. But I always have to add it on both sides. That's important. So 6 over 2 is 3. 3 squared is 9. And so I'm going to have to add that 9 on both sides. Then for the y, I'm going to take the coefficient of y. I'm going to divide it by 2. I'm going to square it, and I'm going to add it. Sorry, divide it by 2 rather, not 1. So 2 divided by 2 is 1. 1 squared is 1. I'm going to add that on both sides. And what I end up with is x squared plus 6x plus 9 plus y squared minus 2y plus 1 is equal to 7 plus 9 is 16 plus 1 is 17. All right. Now I'm going to go factorize both of these, because once I've factorized it, I know what the center of the circle is. And so let's do that. I'm going to get x plus 3 squared. I'm going to get y minus 1 squared is equal to 17. And this is great, because now I've got it in standard form and I can see what the center of the circle is. This plus 3 has shifted it in the opposite direction, shifted it to the left, and so my center is going to be at minus 3. This has shifted it up, and so my y value is going to be 1. That's the center of my circle, and this is excellent, because now that I have the center of the circle, minus 3 and 1, I can work out the gradients of my radius. So I'm just going to erase everything on my board so that I have a little bit more space to work with. I'm going to remember the center of my circle, minus 3 and 1. So the center of my circle is minus 3 and 1. Excellent. Now I know that, I can go work out the gradients of my radius. This was the center. Let me just, oh, that's not very nice. Let me just write it as a C. Excellent. My gradient was y squared minus y2 minus y1 over x2 minus x1, which is going to be y minus y at the top, 5 minus 1, over x minus 2 minus x. And again, whenever I do a substitution of a negative number, I'm always going to do that in a bracket. At the top, I'm going to get 4. And at the bottom, I'm going to get minus 2 minus minus 3 is minus 2 plus 3, which is going to be 1. And so I get a gradient. This is of my radius, which is 4 over 1. That's excellent, because once I have the gradients of the radius, I can work out the gradius of the tangent. The gradius of the tangent, because it's perpendicular, I'm just going to flip it over and change the sign. And so my gradient of my tangent is going to be, flip this over, 1 over 4, and I'm going to change the sign to a negative. Once I have that, I can sub in the point. Well, the only point that I have is this point here, which is minus 2 over 5. I'm going to sub that in. So y is 5, x is minus 2. I'm going to get 5 is equal to, I'm going to do that on my calculator to make sure that it's right. That's equal to a half plus c. I'm going to subtract a half on both sides. I'm going to get c is equal to 4,5. Excellent. I have my gradients, I have my y-cut, and I'm left with minus a quarter x plus 4,5, and that there is my y-cut.